derivative of the tangent. It is the secant squared. So what I'd like to do now is find the derivative of the cotangent. And it's pretty much done the same way, okay? So we want to know what is the derivative with respect to x of the cotangent of x. Well, we don't need to use the limit as h goes to 0 of the difference quotient, which is the definition of the derivative, because we know that the cotangent is the ratio of the cosine over the sine. So it's the cosine of x over the sine of x. And since we know the derivative of the cosine and the sine, we can merely use the quotient rule. So the derivative of the cosine over the sine, remember it's low d high minus high d low over low squared, right? So it's the sine of x, the bottom, right, times the derivative with respect to x of the top, that's our low d high, minus high d low. So it's the top, which is the cosine of x, times the derivative with respect to x of the bottom, which is the high d low. And this is all over low squared, or the denominator squared. Okay, so let's work out what this is equal to. We've got a sine x, and the derivative of the cosine is a negative sine x minus the cosine of x, and the derivative of the sine is the cosine of x, and this is all over the sine squared x. Okay, and what does this give us? Well, in the numerator, sine x times negative sine x is a negative sine of squared x, and this next one gives us a negative cosine squared x over the sine squared x, and we can factor out that negative, right? Because this is actually add the opposite, so this is a negative and this is a negative, which means we can factor out the negative and we end up with a negative 1 in the numerator over sine squared x. Lauren, what's 1 over the sine of x equal to? Cosecant. So yeah, so this is the cosecant, negative cosecant squared x. So the derivative of the cotangent is the negative cosecant squared of x.